Hello everyone. Today we're going to start a new topic. It's about the normal distribution and displaying data, and this is part 1. Let's revise the concept of standard deviation. Standard deviation measures the spread of the data. So if you have a data with standard deviation of 4 and another one with a standard deviation of 0.86, then the first one has more variability and it's more spreaded, while the second one has less variability and it's less spreaded. Okay, and we're going to learn a new concept. It's about the standard error. The standard error is the standard deviation divided by root of the sample size. The sample size is the number of people in a sample. For example, if we have 4 people in our sample, then the standard error will be, if you have a standard deviation of 4 and the sample size is 40, then the standard error is 4 over root 40. Okay, so if we have a population which has a mean of 41, and then we took different samples and we found the mean of each one, then we can see that this sample is the most representative of this population because the mean is the closest. So this mean is closer than this mean, when we compare it with the population mean. So it's the best sample. And the standard error indicates how close is the sample mean to the unknown population mean. So in most cases, we don't know the population mean. And in order to make sure that the sample mean is close to the population mean, we just take the standard error and measure it. If the standard error is small, it shows less variability and the sample may be close to the population mean. If you have a large standard error, then there is more variability and the sample is not close to the population mean, and this is not representative, so it's not a good sample. Okay, so moving to the histogram. A histogram is a type of graph that shows the frequency of a specific variable. So if you have age, it's a quantitative variable, so it deals with numbers. And say we have 1, 2, 3, and so on. Then for 1, the frequency is a specific number, and then we can see that 5 has the greatest frequency, so it's the mode of this population. Okay. Okay, so quantitative, we said it deals with numbers, whereas qualitative is something like color or gender and so on. Okay, so moving to the normal distribution. This is a normally distributed curve and it's really smooth and it's called bell-shaped curve, and the tails never touch the x-axis. So these are the properties of the normally distributed curve. The tails never touch the x-axis, they just go on like this, and the majority of the scores lie around the center. So the majority of the scores are clustered here. Then the mean, median, and mode are almost equal in a normally distributed graph. And this graph is a theoretical one, so it's not real. We just assume that the data is normally distributed, but in reality it's not. And the total area under the curve is 100. Okay, so these are two normally distributed curves. The first one is like more spreaded, so it has a greater standard deviation, whereas the second one is less spreaded, so the distance between these two values is less, but here these two values, the distance is greater. Although the mean is the same, the standard deviation is different, so the shape of the curve is different. So when the standard deviation is greater, the curve will be more spreaded, whereas when the standard deviation is small, the curve will be less spreaded. So if you have a curve with a standard deviation of 1, it will be even less spreaded if the mean is the same. Okay, and this is just the opposite. If we have a standard deviation of 10 in all these graphs, the mean is different, so they have different positions, but the width of these graphs is the same. Okay, so here sampling distribution of the mean is normally distributed even if the frequency distribution and the mean is not normally distributed. So what does that mean? It just means that if we have a population and this is the graph of the population, and then we wanted to take a sample and graph this sample, we will get a normally distributed curve. So after sampling, even if the population is not normally distributed, if we take a sample, it will be normally distributed. There are some deviations from the normal distribution. We have skewness and kurtosis. Skewness is just asymmetry. It's not symmetric. And pointiness means kurtosis. And we're going to look at both of these. Okay, so skewed distribution, you have positive skewness and negative skewness. Positive skewness is like the tail is to the right, so to the more positive numbers. Look at the tail always to decide if it's positively skewed or negatively skewed. If the tail is to the right, then it is positively skewed, and the tail is to the more positive numbers, like here 20, 50, to the more positive numbers. Okay, and this is the frequency, of course, on the y-axis. The most frequent scores are clustered at the left, so it's here. This is the mode, and this here it's the median, and here is the mean. So in all positively skewed graphs, the mean will be the greatest, and it will be close to the tail. So the mean is always close to the tail, and it's the greatest. Then comes the median in the middle, and lastly is the mode. The mode is to the left. It's just the highest point in the curve, because it's the most frequent one. The negatively skewed graph is the opposite. The tail is to the left. Frequent scores are clustered at the right, and the mean is next to the more negative values, just next to the tail, and the median is in the middle, and the mode is to the right. Okay, because it's the most frequent one. So the mode is the greatest, then the median, and lastly is the mean. It's the opposite. So you always look at the tail to decide if it's positively skewed or negatively skewed. The tail decides if it's to the left, it's negative. If it's to the right, it's positive. And now kurtosis. Kurtosis means how pointy or sharp is the graph. So if it's really sharp and pointy, it's a positive one, and more values or categories are clustered at the tails. If it's negative, then the graph is flatter and less values are at the tails. Okay, bimodal distribution. Bimodal means two modes. So we have two modes. If we have like a data of 2, 2, 3, 4, 5, and 5, then the modes will be 2 and 5. These are the repeated values. And this is the shape of the curve. The mean and median will be at the middle. Uniform distribution, it just means that we have one line. There is no mode because all the values have the same frequency. The mean and median are located at the middle. Okay, and this is the normally distributed curve. It shows that a normally distributed curve is made of many tiny bars that are really close to each other, and then the curve is really smooth. And that's it for this video. Thank you for watching.